All right, so Charles's law. Charles was a French balloonist, and was Jacques Charles. So hot air balloons. So he worked out the relationship of volume and temperature, and they are directly proportional. I like to draw arrows. Either they both get bigger or both get smaller. And the idea, again, I think hot air balloons, if I doubled the absolute temperature, the volume also doubled. So what do I mean by absolute temperature? From your reading guide, temperature is going to be measured in what units? Remember? Max, you remember? Temperature, Emily, you remember? Kelvin. So absolute temperature has to be in Kelvin. So you're going to have to do some conversions. It's very easy. You take your Celsius temperature and add 273 to get the Kelvin. So a common mistake is doubling the Celsius temperature does not double the volume. You have to double the absolute temperature. So directly proportional to the absolute temperature. All right, we're going to do 2 of these as an example, then another 5. You're going to do it here quickly. So until you own it, take the extra few moments, write down the equation, it helps commit it to long-term memory. We're going to take a balloon from the room, put it into the fridge. The balloon should shrink. So again, you have to do some reading comprehension. Again, basically volume 1, temperature 1. What are those together? Volume 2, temperature 2. Again, don't think of that as before and after, just what's grouped together. And I see that 22 and 0.5 are grouped together. So I got 0.5 liters, 22 degrees Celsius, and we're going to cool it down to our refrigerator of 4 degrees Celsius. And we want to know what's the new volume. Now, before we do the math, we have to convert Celsius to Kelvin. So we're going to add 273. Thanks. And 273. So I'm adding 273 to both of those. And then to solve, cross multiply, divide. All of these are going to be proportions. Just cross multiply, divide in all of them. And then let's try to do 2 digits. So I'm going to say, so our new volume, 0.47 liters. Second one. Again, until you own it, write it down. Make those long-term memories. Doesn't take very long. Just group 1, group 2. So my first group, I got 0.4 liters and 21 Celsius. And we're putting it into a hot car. Balloon expands. How big does our birthday balloon become? So before we do the math, convert to Kelvin. So we're going to add 273. And again, cross multiply, divide. Something's not right. What did I do wrong? I'm not getting the number I want. Oh, because it's 0.4. Right, I got a really different number. If I write it right. There we go. Let's try it again. That's the number I want. And unless it states otherwise, I should round. You don't have to convert to Celsius unless it asks for Celsius. And if we wanted a Celsius, we just subtract 273. And then just for our American references, if I wanted this in Fahrenheit, I multiply by 1.8 and add 32. So, yep, cars can get pretty hot in full sun. All right, so quick recap. Again, we got Charles's law. All right, volume temperature directly proportional to the Kelvin temperature, absolute temperature. And we add 273 to get Kelvin.